So let's get started. So geometry super review. So we're going to talk about a lot of the different geometry questions for this one. Sorry, sometimes my thing is a little bit scrolly.
That's okay.
So my name is Paul, and I've been tutoring for a long time now. But I think the biggest thing that I'll say to take away from this one is just really make sure that you're thinking about strategies for geometry
Mhm.
problems. Always make sure you're writing down any equation for that question. And then drawing any type of image for that question. And then also when you write out that equation, plug in all the values you know or that the
Mhm.
problem is giving you. Oftentimes it's going to tell you what you need to still solve for, right? Or how to get to that answer choice. Okay.
Yeah. Okay.
So the first thing is test optional versus test blind. This is just one of those things to kind of keep in mind. With test optional versus test blind, test blind means that the school will not look at your test scores at all, right? They're just not
I
going to look
see.
at anyone's test scores at all. Test optional means that they can look at your test scores and they will look at them when they're comparing you with another student, right? To try to figure out who's going to come to the campus or not, right? Or who they're going to admit or not. So if you're applying to a test optional school, it's always best to still take that test, especially
Yeah.
if you're looking at some of those competitive schools. Do you have any ideas of some of the schools that you're interested in applying to?
Uh, I'm still looking at some, but maybe Seattle U or somewhere random like Azusa or something.
Okay, yeah, for sure. Yeah, so even with that being said, like one of the big things is just really making sure that you look at those schools ahead of time. You want to make sure that you're already starting to think about that application or what that process is. I know it's
Yeah.
a little bit away, but just making sure that you get ahead of it because there are some students that wait to the last moment, but like early decision is one thing, letters of recommendation are another thing, right? So there's a long
Yeah.
process. So really making sure that you're getting ahead and figuring out what the schools you're applying to want, right? Are they test
Mhm.
optional? Are they test blind? And then what do you want to do with that one? Okay, cool.
Yeah.
Awesome. All right. So our agenda for today, we're going to go over a few different things. So we're going to start out with geometry, the importance on the SAT and the ACT. Then we're going to talk some about angles, polygons, circles, triangles, 3D shapes, and geometry, coordinate geometry, and then SOHCAHTOA, and then just some recommendations. Okay.
Okay. Sounds good.
I don't know why this thing is going really slow right now. All right. Give me 1 second. I'm going to see if I can close something and see if that helps out. Okay. That's a little bit better. No, that's okay. Let me see. I'm going to close this, and then hopefully that helps out way better. As far as the geometry on the SAT, there's 2 math modules on the test. 35% is going to be algebra based. Then you're going to have advanced math as well, and then problem solving, data analysis, and then geometry and trig, right? So there's
Mhm.
only going to be about 15% of geometry and trig questions that are going to be on the exam. So we really want to make sure that for those questions, all right, let me see if this works better now. There we go. I think that's good. So we really want to make sure that we're focused on the geometry and trig, right? So 50% of the math is not coming overlapping between algebra, coordinate geometry. And then as far as geometry on the SAT, there's going to be around like 3 to 4 questions, including like your angles, your trig, all those different portions. Okay. So let's keep going. As far as geometry on the SAT, they're going to give you these equations. What I typically suggest for students to know are going to be, I think that I think that that's why it wasn't working. Okay, there we go. Sorry about the technical difficulty. I think
No, it's okay. No worries. Yeah.
there we go. All right. Okay, cool. These are going to be the main questions or main equations that I'd like students to know. Even though they give you this on the SAT, it's good to know these because there's going to be some questions where it's going to save you a lot of time if you just know those general equations, right?
I
This
see.
one, your special right triangles. I'm not sure if you're familiar with these. Have you seen these before?
I think I've seen the one on the right. I don't think the left one though.
Okay. So yeah, so these are just really good to know because there's going to be some questions where you're going to see something like a square root of 3, or you're going to see something where a side is going to be 2 times the other side. And
Mhm.
just knowing those really helps out because it makes it a lot easier and a lot simpler to kind of answer some of those questions, right? Because then you know you can come here and use your special right triangle tricks. And then this is the same way. If you see like a square root of 2, that's probably going to be something that relates to a special right triangle if you're having triangle questions. Okay.
I see.
You're not taking the ACT, but yeah, ACT again, as far as that one, section 2, there's going to be 60 questions. Also, the ACT is actually going to be changing, where they're going to have a digital version and it's going to be a little bit shorter in the future as well.
Oh, I see.
So as far as our basic approach, right, we want to always, again, draw our figure, whatever figure is for that image. If they don't give us a figure, we want to draw it. We want to label the figure with everything that they're giving us. We want to write down all our equations. And then sometimes we're going to want to ballpark, right? So we may not necessarily have to solve everything. So as far as angles, figures are not required to be drawn to scale, right? So some figures that you're going to see on the exam may not be drawn to scale, so we have to just be careful with that. Use the numbers that are given compared to what the figures are. As far as your vocabulary, do you know what supplementary complementary angles are the first two?
Oh, I learned geometry in like long ago.
Okay. So supplementary angles, basically, those are going to add up to equal 180.
Oh, okay.
Complementary angles are going to add up to be 90, right? So in this case, if we're thinking about supplementary angles, right, this angle right here, this angle right here, and this angle right here would all add up to equal to 180. And then if we're thinking about like complementary angles, let's say if we use this and this one, those two are going to add up to equal to 90. Okay. And then your vertical angles are going to be the ones that are on the opposite sides, right? Tangent is basically a line that's tangent to a circle, right? So basically it only touches at one point. So this is your tangent. Your similar angles are going to be the angles that are going to be the same. So basically if you cut something like this, right, your similar angles are going to be like this angle, this angle, this angle, and this angle, right? So those are
yeah, I remember.
one, right? And then when we're thinking about parallel versus perpendicular, right? What is parallel lines? What are those?
I can draw it. I just can't describe it. So they're not touching, but they won't like
Exactly,
intersect.
right? They never intersect, right? So those are going to be parallel. And then perpendicular lines are going to be ones that are at 90-degree angles. And the slope of those is going to be like the negative reciprocal. I think we may talk about that a little bit later. Bisecting just means you're cutting an angle in half. And then your interior or exterior angles are basically going to be the ones that are inside compared to outside. So, but overall, like I said, I think you should be good on those. So let's get into some of this math part, right? So this one says in the figure above, lines A and B are parallel. Lines C and D are parallel as well. If the measure of angle 2 is 105, what is the measure of angle 1, right? So what we want to do in this type of situation, whenever you get an angle question, draw in the values where they go, right? So we know that this is 105. We said that the other angle opposite of it is going to be 105, right? And then we can just kind of like start to make our way around, right? If this is 105, right, then we know that this angle right here is going to be what? Sorry, this angle right here is going to be what?
Is it going to be 180 minus 105?
Correct.
Which is
75.
75, right? 75, yeah.
Yep. And then that means that this angle right here would be what? Which means this angle right here would be what?
Oh, 75.
Or this one's actually going to be the same.
105, yeah.
There you go, 105, right? So one thing to kind of keep in mind is that also when you have a triangle like this angle right here and this angle right here have to equal 180 as well.
I see.
Right? So now we know that this one's also going to be 105. So we can go with D as our answer choice. So whenever you get like angle questions or triangle questions, the biggest thing that we want to do for those is just really draw in our individual angles. Okay.
Okay.
Awesome. All right. Let's check out this next one. So this one gives us this question. In figure shown below, the measure of angle EDF is x minus 15, and the measure of EDG is 90. What is the measure of FDG? Okay. So how are we going to solve this one? What do you think?
So you put in the x minus 15 where the EDF is.
Okay.
And then since it's 90, it'll just be 90 minus x minus 15.
Okay. Right. So 90 minus x minus 15. Right. And then just remember, whenever you're plugging in a value, always put parentheses around it where there's going to be like a negative, just because that helps you with that distribution, right? So this is going to be negative, and then we know this right here is also going to be our negative, right? So now we're looking for FDG. So now what is FDG going to be once we do our math out?
It's going to be, is it the 85 minus x?
So so go ahead, write it out on your paper.
Okay, so it'll be 90 minus x plus 15, which is 105 minus x.
Cool. There we go. Right. And one of the things that I want to point out is a lot of times for some of these questions, you're going to be able to use your process of elimination, right? We know there's going to be a minus x. So we know that we can get rid of anything that has like a positive x, right? So that means that like G we could get rid of. That means that K we could get rid of. That means that F we could get rid of. And just like that, we would only have two answer choices, right? So process of elimination is one of those strategies that can really help us out with these individual questions, okay?
Okay.
Awesome. All right. So for these are just equations that you want to know, right? So as far as the area of a square, it's just going to be your side length squared, and your perimeter is going to be 4 times your side lengths, right? As far as a rectangle, you're going to have your area is going to be your length times your width, right? So basically the same thing is here, your length times your width, but these are just going to be the same. And then your perimeter is going to be 2 of your length plus 2 of your width, okay? And then just remember that the sum of all 4 angles of any side or shape is going to be equal to 360, right? So this, this, that's going to be equal to 360. It's easy to kind of think about that because we know that all of these are going to be 90-degree angles.
Yeah.
So if these are 90-degree angles and you have 4 of them, then that's going to get you to 360. Okay, awesome. So let's check out this question. It says, what is the area in centimeters of the figure below? Well, one of the things that we want to think about with these types of questions is, let's try to break this shape up into figures that we know, right? That make it a lot easier. So we could do something where we break this into 2 figures, where this is going to be figure 1 and this is going to be figure 2. So if this is figure 1, right, we know that we have 20 centimeters here and we have 20 centimeters here. So what would be the area of this one? Well, we write area is going to be equal to length times width. So what is the area of figure 1?
400 centimeters.
Okay, cool, equals 400. And then what about for the area of 2?
Well, the length is 20 minus 6, so it'll be 14 times 10.
Well, we know this
so...
one is 6 right here, right?
Oh, 6, yeah.
What is the height?
10, right?
10, exactly right, because we see that this is 20 and 30. So we get that this is going to be 10. So now what is going to be the area of 2?
60.
60. There we go. Right. And also, right, this is one of those problems, and you'll see this, you'll be like, wow, there is a lot of places where we can use that process of elimination. For this one, as soon as we saw that this was top part was 400, this goes away, that goes away. And then this area is so small, right? We know that it's not going to be 720 and it's probably not going to be 600 either, right? So even if it's that approximation for some of those questions, sometimes you can use a combination of solving them out and approximation. Remember that the score that you're going to get, or I should say, the way that you're going to get points on the exam is by getting answers correct, not necessarily about how you solve the problem or how much time you spend on the problem, right? So our big thing is, how can we get to the answer as quick as possible, okay? All right, so check this one out, read this, and then I'd like you on your paper to try to solve this one out and set this one up using the equations that we talked about, and then we'll go from there.
Length is L with 12, so L minus 12. Is it 4L minus 24?
Okay, awesome, right? So great job, right? So we want to just make sure that we're thinking about how we would put this one together, right? And then just thinking about this part, right? So in this case, the length of the dining floor is L feet. So we always draw out our picture, right? So the length is L feet and the width of the floor is 12 feet shorter than the length, right? So in this case, width equals
L minus 12.
There we go, L minus 12. Right? So now we have L minus 12, right? And now we can think about the perimeter. We're just going to add all those together, right? So we have that L here, the L here, the L here, the L there, and then the 12s right there. Great job. So again, for those problems, we're just always trying to draw out our shapes in our images and then using those to solve the problem. Okay. Good job. Parallelograms and rhombuses. Have you worked with these, or do you remember these from math a long time ago?
I think so, yeah, I'm pretty sure.
Okay. So one thing that I just want to point out is these are very similar to rectangles in a sense. They may not seem like it, but what you think about with rhombuses is that if you were to take this side, right? I'm just going to draw this quick and take that portion and just move it over here, right? What would you have? And if you would have got rid of this portion right here, then you would basically have a square, right? Or a rectangle. So that's why the equations for these are very similar, right? So for this one, it's the same type of thing. The area for this is going to be your base times your height, right? Or if we would have put this one over here, it would have just looked like our length times our width in a sense, right? So that's why the equations are very similar. So when you're working with a parallelogram, all you want to think about is just your area is going to be equal to 1/2 base times height, okay?
Okay.
So with these, just the opposite sides are going to be the same. They're all going to be parallel, and then opposite angles are equal, right? So in this case, this angle and this angle are going to be the same, and then this angle and this angle are going to be the same. And the same thing that we were talking about before, this angle plus this angle are going to end up equaling to 180, okay?
Okay.
And for a rhombus, all 4 sides are going to be equal, right? So for a rhombus, you can have something like this. This is also, a square is also a rhombus as well, right? So just make sure that all sides are equal for a rhombus. Okay, cool. Okay, so let's check out this question, right? And again, remember, we don't necessarily need to solve out every question. Some are just going to be reasoning type of things, right? So this one says a kite has a perimeter of 54 centimeters, and one of its side lengths is 12. If it can be determined, what are the lengths of the other 3 sides? So which ones can we get rid of? Which ones can we use process of elimination to get out of to get rid of?
H and J.
Okay, H and J. Cool. And then why can we get rid of H and J?
Because if one of the sides is 12, that means another side has to be 12. But there's
Okay.
only one 12 in those.
So, but that means that we would have another side that's 12, right?
Yeah,
Because
yeah,
we're
yeah.
asking about the other three sides. So
hmm
which ones actually can we get rid of?
Just 8. Oh,
We,
no, no, no.
so if we had these, then that means that we would have three sides that are 12. Does that make sense? Because we have one
Oh, I
that's 12,
see.
and yeah, right. So in that
Oh, I
case,
see, I see, I
just
see.
because of this, we know that we can get rid of those two
Yeah,
people, right? So these
yeah.
other two are still possible, right?
hmm
Because we know that we have that 12 there, and we should be able to determine this, right? Because we have some type of rhombus or whatever, right? So at least
hmm
we know that part, and then we can just use our math, right? If we have these, what's 12 plus 12? That's going to give us 24. Well, how much are we going to need left over? That's going to be 30. So if it's 30, then we can get rid of these because we know 15 plus 15 is going to give us our 30. There's a process of like that process of elimination, and then we can kind of think about it. A lot of times I like to use process of elimination, not necessarily just on the math, but also on the reading section.
mm
What it allows you to do, it allows you to get rid of like that extra thinking part, right? Again, that's one of the main things to kind of consider. Awesome. Now with trapezoids. So trapezoids are a little bit similar, but they're a little bit different, right? So trapezoids aren't the same as rhombuses, right? We have different types of situations, but again, our angles, the ones that are opposite of each other on the same side, are going to be equal to our 180. So that's good to know. The other thing is that our equation for the area of a trapezoid is going to be our base 1 plus our base 2 divided by 2 times our height. Okay. This is basically what we're doing is we're just using that middle portion to kind of think about what the height is going to be, right? Or what the height would be at the middle part, right? Because if we did this one, again, that same type of trick that I just showed you where we would make this into a triangle, right? That's going to be the same thing as this triangle up here, right? So that would basically be a square. And then if we did that over here for this one, right? And we put that over here and cut that out, then this would be basically be a square. So we know that the amount that we're going to is at the middle. And that's why our equation is base 1 plus base 2 divided by 2 times our height.
Will that be like the formula on the test? Or do I have to
This
memorize?
one is not given on the exam. So this would be one that you will want to remember.
Okay, got
But as long as you can remember, it needs to be right in the middle, then that makes it a little bit easier.
it.
Awesome. Cool. Let's check this one out. So it says for the trapezoid WXYZ shown below, segment WZ and segment YZ are parallel. The measure of the interior angles are distinct, and the measure of angle W is A. What is the measure of angle Z in terms of A? So remember that in this case, we said that this is A, and then we're trying to figure out the measure of angle Z. What do we say about these two angles? The one that is right here and the one that's right there.
Equal 180. So whatever. So just 80 degrees minus A degrees equals X.
Okay, exactly right. So 180 degrees, right, minus our A is going to be equal to our X, right? And again, could we use some process of elimination for this question?
Yeah.
Exactly right. We know that we're going to minus the A. So anything that's plus a A doesn't work. A by itself, we know doesn't work. And then also, we don't need to have a half A, right? So even from that question, right, we didn't even need to do any of the math really. Like we could think about that process of elimination. So again, when you get to problems, what I like to do is I like to always try to think about how am I going to attack this problem, right? Before you start working through it, think about how you're going to attack it. And that's going to make it a little bit easier when you're trying to go through some of those questions. Okay. All right. So polygons. Have you worked with polygons recently?
Not recently, but I vaguely remember it.
Okay, cool. So the biggest thing that I'll say is that with polygons, the sum of the interior angles is going to equal 180 times n minus 2. If you're ever not sure about that, you can kind of think about a square. We know that there's 4 sides, and we know that the sum of the angles in this one are going to add up to equal to 360. So in this case, if we know that there's a 180 times what is going to get 360, well, we know that there's a minus 2 or something like that, and we just have to think about it's going to be that n minus 2, right? So another way to kind of think about it. So it's just going to be the number of sides. All right. So let's check out this question. It says x is equal to 180 minus 360 over n. Okay. Don't know what that means. Right. And then one thing that I want to say is that, especially for like those long word problems, right? One of the best things that I like to do is try to read the question portion first. So the last sentence, so that I know what I'm looking for when I start reading through, right? So if the measure of the interior angle of a regular polygon is 100 degrees, what is the least number of sides it can have? Well, okay, cool. So we know the specific question is greater than 100, right? So that means X is greater than 100, right? What is the least number of sides it can have? So now what do? Well, we just plug our values in to our equation. So in this case, we have 100 equal to 180 minus 360 over n, and then we solve for n. So try this one out on your calculator, or what's there paper in your calculator, and then let me know what you get for n.
Can I use a Desmos calculator?
Yep, that's fine. Yep, because you'll have that available for the exam as well.
It's on the denominator.
Awesome. No, great question, right? So we have our 80 is going to be equal to, well, we subtracted that, and then we have this one, 360 in. So whenever you have a fraction like this, all you need to do is cross multiply, right? So we can bring that in over here. Yep, right? N is equal to 4.5, right? And that's 100, right? So we want to say, what's the least amount of number that it can have? So if this is 100 and we get N is equal to 4.5, then what would be the least in that case? Well, if we had 4, then we would be a little bit too low, right? So we actually have to go up to 5 because, yeah, we have that 4.5, right? Because if we did 4, right, then we wouldn't get to our value. Okay. So with these types of questions, right, what we always want to think about is, what are we solving for? And then how is that exactly what we're looking for, right? And then just kind of think about that reasoning. If you're never sure, or if you get between 4 and 4.5, then there's a good way to check. You can just plug those in, right? So that's another strategy that we didn't talk about in this case, but there's one strategy where you can use. It's called plugging in the answers. Have you heard of that one, or have you used that before?
Oh, yeah.
Okay.
Just plug that in, right?
Exactly, right? So when you're plugging in the answers, typically I say start in the middle, right? So what you could have did for this problem also is you could have plugged in 4 for this, right? And then if you would have plugged in 4, you would have got 90. So you would have got X is equal to 180 minus 360 over 4, which would have given you 180 minus 90, right? And then that would have gave you 90 as your angles, right? So we know that it has to be more than that, right? And that didn't get us up to our 100, right? So we know that we'd have to go up to 5, right? And if we did 5, we get that value. All right. So this one looks a little bit more tricky. Looking at this one, again, I like to go to the questions. If the angle of the area of the rectangle is this in square inches, what is the area in square inches of the hexagon? So in this case, do you have an idea of how to potentially answer this one? Okay. So let's say that this, right? So we know that this has side lengths of A, this is A, and these are A. So we know the side lengths of all of this, and then we know the area of this rectangle is going to be equal to 144 times the square root of 3. So that's all we know so far, right? So what we can do is we can say, all right, if we know that area, what else do we need to know? Well, we need to know, I'm sorry, there we go. So if we have this area, what else do we need to know? Well, we need to know what this part is. We need to know what the volume of this, or the area of this is, and the area of that is as well, right? But we don't really know all of that material. So what can we do? Well, in this case, there's a couple different things that we can think about. If we know that these are all A, and then this is that portion, we can say that we know that this part is going to be our length, or this is our length, and that part's our length. And then if we basically take our length and we divide it by 2, that's going to be this side. So we're going to have our area times our length. And we know that these triangles are, what's the area of a triangle? What's the equation?
Base times height divided by 2.
Exactly. 1/2 our base times our height. So in this case, if we know the area of this one, what's it going to be? Well, we need to figure out what's going to be the different values that we're going to have over here. So in this case, if we think about our area, well, our base is going to be equal to our length divided by 2, right? And then our height is going to be our x, or we can call it our x. And we could try to figure that out using like some type of Pythagorean theorem or something along those lines, right? So that'd be one way that we can kind of think about this one, right? The other thing is, what was I going to say? The other thing is, wait, actually, I don't like the way, I feel like there's a piece of information that's almost missing from this one, because we're not going to be able to find out our L directly. It'll have to be proportional. But yeah, I think what they did with this one is they're basically trying to show that, let me see. Yeah, actually, yeah, I'm not sure with this one. I feel like there's something that's kind of missing with this one, because even if you break it in half, that's not going to help you out. If you do a straight line, it's not going to help you out. Yeah, you'd have to do a complex equation for this one. And I don't think that that's what this one was supposed to be doing. But yeah, for this one, you'd have to use some type of complex equation where you're setting up the different types of areas and then relating those that way. So I would say for this one, don't worry too much about this question for now. But yeah, I'll say that for now. Okay.
It's okay. Yeah. Like you said earlier, and find like it as two hexagons, or I mean trapezoids.
Yeah. So the tricky thing. So let's see. So you're saying to draw a line. So let's see. You're talking about vertical line.
Yeah, vertical line.
Okay. And then you're saying to draw a trapezoid.
Oh, yes, it's like since you split it, they're both like trapezoids on both sides.
Yeah. Yeah, that would be kind of interesting. I think the biggest thing that's just kind of tricky with this one is I think I know what this one's supposed to. So sorry. So this is where this one comes from. So we had our angle. So 180 and n minus 2. So what would be the angle for each one of those sides if we have 6 sides?
So it would be like 6 minus 2, 4, 120.
720 would be for the whole thing. And then how much would be each side if we divided that by 6?
120.
Okay. So if that's 120, right, then we can do this and we can say that if that's 120 and we know that this is a 90-degree angle, that this one is going to be equal to 60 and this one's going to be equal to 30. And then we have that thing that we talked about before. Remember that 30, 60, 90 triangle? 30, 60, 90. And we know that this side length is A. So that means that this portion down here, the smallest side would be A over 2. And this will be A times the square root of 3. So if we bring that back to our triangle, then now we have this. We have that this side is A. We know that our height is going to be A divided by 2. And then we know that our side length over here is going to be A times the square root of 3. So now, because of that, we know that this is also going to be A times the square root of 3. And because our interior is equal to 144 times the square root of 3, and we know our equation down here, so let me erase this part right here, then we can start plugging in our values to figure out what A is, right? So our area is going to be equal to what? Well, we have these two together are going to be our length. So we have area is equal to 1/2 our length. Oh, sorry, two different equations. So this one's for the triangle. So this one is for the rectangle. So this is area equal to our length times our width. And our length is going to be A. And our width is going to be 2 times A square root of 3. And that's going to be equal to 144 times the square root of 3. So then what we can do is we can solve for our value of A from this equation. And then once we solve for our value of A, then we can solve for the other triangles as well, right? So for time, we won't go through that, but just kind of showing how we would do the A part, we would take it out. So we'd have 144 times the square root of 3 is equal to A, and we can factor that out. And then we're left with 1 plus the square root of 3, or sorry, 1 plus 2 times the square root of 3. Right, it's going to be equal to A, and then we divide that by this portion over here, right? And then once we divide that by this portion, then we can get our A value, and then from that A value, then we calculate all the side lengths and then do that triangle portion, right? So I will say that the SAT does have some complicated questions like this that do take a little bit of time, especially later in the exam. So you just want to make sure for those questions that you are just looking for ways to kind of start it out, right? Sometimes you're going to have to like draw different things as well. So even like with you kind of like talking about that vertical line, right? It kind of changed it around a little bit because now it's like, oh, this is the 30, 60, 90 type of triangle. And we can use that type of relationship to solve it out. But again, there are going to be some problems that are a little bit more challenging. So you want to make sure that when you're in the exam for those earlier questions, really make sure to spend time to get those ones answered correctly. And then once you get to those later questions, you're going to need a little bit of extra time. So just, again, it's just that process of making sure you have enough time for those. Okay. All right. So for circles, right, this question is going to be, there's only two main equations that you're going to need for circles: the area of a circle and the circumference. A good way to kind of remember these are you have your pi r squared, right? And then for your area, and then for your circumference, all you basically do is you bring that 2 from there to the front. So your circumference is going to be equal to 2 pi r. So that's a quick way to kind of remember those two. So again, when we're going through these questions, what do we want to do? We always want to draw out our equations as much as possible and draw out our pictures and then use those to help us solve the question, okay? So this one says a circle with a radius of 8 is divided into 5 congruent angles, right? So first let's draw a circle. Actually, let's draw it down here. A circle with a radius of 8. So let's draw a radius of 8 is divided into 5 congruent arcs. Okay. So we know that there's 5 congruent arcs. We'll just try to put them on here, something like this. So that means that, what's congruent mean, by the way?
It's like equal.
Exactly, right? They're the same, right? Or equal, right? So 5 arcs that have the same length, right? And it says, what is the length in inches of each one of these arcs? So how are you thinking about solving this, right? If we know that we have 5 arcs, we have our radius. What are you thinking?
Can you like split it like all the way, or does it have to be like the small marks on the circle?
So those are just 5 random marks, right? But they're all congruent, right? So we know that the arc is just going to be our distance.
Yeah, okay.
from
And then
here.
since the radius is 8, then you can just measure like the angle of like with 8 being one of the sides.
Well, maybe possible. So what is going to be our distance around the whole circle, or distance? So that's the degree. But what
distance.
about the distance? Or what is that called? The distance around a circle.
Circumference.
Circumference, right? So what is the equation for a circumference?
Oh, 2 pi r.
Perfect. 2 pi r. Great job, right? So now if we have this and we know that that's the distance around the whole circle, how are we going to find out about each individual one?
Oh, is r the radius?
R is the radius.
So you'd plug in 8 for r.
Okay, cool, right? So we get that our circumference is going to be 2 pi times 8, or equal to 16 pi. And then what are we going to do with that 16 pi to find out all the 5 different arcs?
Divided by 5.
Divided by 5, right? And then what will be our answer choice?
B, 16 pi.
Great job. Great, right? So even with that one, right? And I was going to bring back that process of elimination, right? We know that we're going to have to divide by 5 or something like that at the ends. These are probably not going to go because there needs to be that. Just trying to figure out their circumference is going to be that next part, right? Great job. All right. So this one's a little bit more of a challenging type of problem, right? But let's look through this one. So it says, what is the ratio of the area, right? Again, reading that last question part first, so we know what we're doing. What is the ratio of the area of both the small circles and to the area of the large circle? Okay, so let's check out the top portion now. The figure illustrates 2 small circles that are inscribed in a large circle and are tangent to A and C. The center of the large circle lies beneath the smaller circles. The diameter of the large circle is 20 inches. Okay, so this one is actually pretty interesting, right? Because we know that this whole thing is going to be 20 inches, right? From here to here, we have that this part is going to be equal to, I'll write it down here, it's going to be equal to 20 inches. So what are we doing? Well, we're trying to figure out the area of our circles. So what is going to be the area of a circle? What is the equation for area of a circle? R squared. Perfect. And then we know that this top one is going to have an area of 20. And then we also going to have the smaller ones, right? So let's say the smaller ones, we're going to have area. So let's take the area of the large one, area of like the small one, the first one, and then area of the small one, the second one, right? So they're all going to have pi r squared. So I'm going to just call this pi r CA to talk about the CA part. And then I'll call the other one AT, okay? So now what we're trying to think about is what? Well, how can we figure out these different values? Oh, sorry, what were we saying? No worries, right? So in this case, we know that this radius of this top one is going to be 20. What about the radiuses of the small ones? Oh, sorry, what?
Are they going to be half 20?
Exactly, right? Because these are 2 circles that are meeting at the center. So we know that these are both going to be 10 and 10, right? So in this case, we know that when we're thinking about the ratios, we have the ratio of the first one, which is going to be pi times 20 squared, right? And then we're comparing that to what? We're comparing that to pi times 10 squared plus pi times 10 squared. So what is going to be the area of the left one when you multiply that out, or this portion? What is that going to be? 400 pi, or just that side, right? And then what are you going to get with these? What is 10 squared? And then plus 100 pi. So now if we think about these two, what's going to be the relationship now? We have 400, and we can probably cancel out the pi's because they show up on both sides, right? And then that's going to be 400 to what? 200. So in that case, our ratio is going to be 1 to 2. Does that make sense?
Yeah, that makes sense.
All right. So again, we just want to make sure that we're drawing as much as we can. So you see how much work I did as far as like writing out everything on this exam, right? That's what you really want to make sure you're doing, right? Writing out everything as much as possible, right? Because what we want to make sure that we're doing with these questions is trying to trying to like limit small mistakes, right? And then also get the thoughts out of our head on the paper, right? One thing to kind of consider is that with the way that our brains work, there's only typically around like 6 or 7 things that it can kind of like hold on to at the same time, like when we're going and thinking about different things. So if you're in the exam and you're thinking about where you parked your car at, like thinking about the break, thinking about the past session, or what you might be doing afterwards, or reading the question, and then you're trying to remember everything as you're going along, it's hard to keep that, and it's where errors start to come into place. So that's why you want to make sure you're writing as much as possible, whether it's on your scrap sheet of paper. Well, you're doing SAT, so yeah, on your scrap sheet of paper, you want to make sure you're writing out as much as you can, labeling out as much as you can, and then going from there. You will have your annotation tool on the exam as well. Have you tried out any of the digital tests yet, by the way?
PSAT last year
Okay.
on digital, so yeah, I'm kind of familiar with how Blue
Okay, cool. I'd say, yeah, if you have a chance, I'd look at or just take one of the like College Board has free SAT exams that you can go in and like try out. I know it's not the same as the PSAT, but let you get a chance to kind of see how that Desmos calculator works in that one, as well as the marking for review tool as far as your annotations as well. So I say, yeah, if you have a chance before the exam, definitely look through one of those. You don't have to enter all of them, but it'd be a good time to just kind of like check that out. Okay. And then circles, arcs, and sectors. So we talked about arcs already. So an arc is just going to be this portion. And then what is a sector? Have you heard of a sector before? Okay. So sector is basically just like a slice of pizza. It's just basically the area of, right? So the cool thing is that because of these, we can do some simplistic type of equations, right? We can say that our central angle divided by 360, right? Because that's kind of like our part of our whole, right? If our central angle is here, let's say that that's going to be 60 degrees. Well, what's the rest of this circle? The rest of the circle is going to be 360 degrees, right? So that's going to basically be our part divided by our whole. So we can use that central angle and understanding that compared to 360 degrees is going to have that same proportional relationship as our arc length over our circumference, right? Because that's the same distance type of thing, right? Or our sector to our area. So we're just taking our part, which is going to be our arc length, divided by our whole thing, that's our sector, or our area, or our circumference, sorry. And then our sector divided by the whole thing that we have as far as if we shaded in all of this, right? Which would be our area. And that's why we have our 2 pi r and our pi r squared, okay? So let's check out this question. So it says in the figure above, point E is the center and the area of the sector DFE is 1/6 of the area of the circle. What is the value of E? So as soon as we see this, we want to draw out our circle equations, our arc equations, right? So we know that we have our central angle divided by 360 is going to be equal to what? Well, we talking about our arc or our area. So it's going to be equal to our sector divided by our squared, right? And now we want to figure out how can we use the other information, right? So they said that this major sector is 1/6 of the area of the circle, right? So if this is 1/6 of the area of the circle, right, we know that this sector is basically, in a sense, 1 of that circle, right? So our sector over our area is going to be 1/6. Does that make sense, by the way?
Yeah.
1/6, right? So if we know that, I'm just going to put it over here because it makes it a little bit easier. Then how do we figure out our central angle from this point? Okay, cool. And then how do we get our central angle at that part? Exactly, right? So we can cross multiply. And then what's 360 divided by 6? There we go. Great job. 60, right? So then we have our 60 there. And then we know that this angle is going to be 60. So anytime you have a sector question or an arc question, you just write out that equation, right? Your central angle divided by 360 is going to be equal to your sector or your arc. So in this case, if we had our arc divided by our 2 pi r, or we have our sector, and that's going to be divided by our pi r squared. Questions? Awesome. Great job. Okay, so check out this question. And then I'd like you to try this one out and think about how to set that one up, okay? So I'll give you a minute to solve this one. I'll give you a minute to, solve this one, okay?
I set it up like 360.
So let's see. So we have this one here. And then we know that our arc is going to be 9 pi over 4, right? And that's radians. So the other thing you can think about is we used the other one where we had our central angle divided by 360. Another thing you can kind of think about is we can also think about that in radians, right? So if we had our central angle in radians, how many degrees or how many radians is 360 degrees?
Sure, actually.
No worries, right? So 360 degrees is also going to be 2 pi radians. So in this case, we can also think about it this way, 9 over 4 pi divided by 2 pi radians, because that's going to be our whole thing. And then once we do that, we can just go ahead and solve that one out. So how do you do 9 pi divided by 2?
You just do 9 divided by 2 pi.
All right, so 9 over 4, and then that's going to be our pi, and then we're multiplying it by what? We're multiplying it by reciprocal.
1 over 2 pi.
There we go, right? So now we can cancel out our pi's, and then we get that this is going to be 9 over 8 once we multiply it out. Cool. All right. So again, all we're thinking about is what is our part and what is our whole, right? Our part is going to be our central angle, and the whole is going to be our complete circle. All right, triangles. How are triangle problems for you?
A lot easier than circle, I would say. I feel like I'm more familiar with this because we still use it now.
Okay, cool, right? So again, we'll kind of go through this one a little bit quickly. Again, area is going to be 1/2 base times height. The sum of all the angles are going to be equal to 180. And then as far as like your triangles, saline has no angles that are the same. Isosceles has 2 angles that are the same. And equilateral has 3 angles that are the same. So what you want to do when you get to these types of questions, right? When you're in a triangle question, just start to fill in the angles that you know until you get to that part that you're looking for, right? Similar to when we were talking about it earlier and we were looking at the 2 parallel lines or the 4 parallel lines, right? We want to kind of think about that same thing. So what angles are going to be the same, which ones are going to be different, and then we just want to go from there, okay? Always make sure as well that you label anytime that you have congruent sides or congruent angles, right? So anytime if they're the same. And to do that, you just see where it's AD. AD is right here, and DC is right here, right? So we always want to label the angles that are the same, right? And just remember, not all of our images may be drawn to scale. So if we do those two the same, what can we start to do to kind of start to solve out this triangle? What are you thinking?
Fill in some extra missing angles that we don't have.
Exactly, right? We're trying to figure out which other missing angles can we start to solve for. So if we're starting to solve for angles, we know that we have 40 here. This one's 104. So what other angles can we start to fill in?
6.
No, that's going to be 76. Awesome. What else can we figure out now?
It'll be 180 minus 76 minus 40.
Okay. And then let me know what that one's going to be.
64.
And then where do we go next?
Do the other 64 from the other triangle.
Awesome. And then what else can we do at this point?
And I'm pretty sure that the x degree is 76 as well.
Not necessarily, but what can we do with those congruent sides? What do we know about this and what that means for this angle and this angle?
No, they're the same.
Those are the same. So let's call those y. So this is y and this is y. So what's going to be the measure of y?
Y is...
And I'll do this to help out. So this is the triangle that we're looking at.
It'll be like 104. So 180 minus 104 minus 2y.
Or yeah, right? So 180 minus 104, right? And then we get that that's going to be equal to 76, right? And then how do we figure out our y's?
Do you solve for y?
Okay. Well, what are y's going to be? That's the remaining angles. And we have 2 of those. So we can just, divide by 2. Thank you. Right. So if we divide that by 2, right, that's going to give us what y is. So what is 76 divided by 2?
38.
Okay. So now we know that this is 38. So now what is this angle going to be here? There we go, right? So just remember with these questions, you always want to draw out as much as possible. You don't want to make that assumption, right, that they may be the exact same, because then these answers are there to trick you up and they're there to make you feel comfortable. So you just want to make sure that you do that part. But again, always label your congruent, and then just remember that you can kind of put together your triangle as you go along. Okay, awesome. Great job. All right. So you're pretty good with triangles. So I'm going to let you try this question out, read it through. And then when you get done, let me know what answer choice out of the ones at the bottom works best.
Be like the exact thing down.
Yes, exactly. Yep.
I'm just a tiny bit stuck.
No worries, right? Let's kind of like work through this one and just talk about a couple of different things, right? So let's break down the question and then start to utilize that. So we know this is 35. So what was the first thing you started to do?
I just went to 35, the other side.
Okay, so 35 here. What else do we know from the question?
In H and Y.
So we know that this is isosceles. What is isosceles triangle?
It's less than 90 degrees.
Not necessarily less than 90 degrees, right? But isosceles means that the XH and this HY are going to be the same. So these are going to be congruent. So we know that this angle right here and this angle are also going to be the same. And we know that this angle and this angle are going to be the same. And this angle and this angle are going to be the same, right? So we know that these things are going to be all congruent. And then we also know a couple different things. We know that this angle right here is also equal to that angle right there. So we can start to kind of figure out a few different things, right? And then we know this is 35, right? So if that's 35 and this is 35, and then these are parallel, right? What does that mean about this angle over here? What's that going to end up being? Well, if this one is the same, right, and this is the same, then that means that this angle right here has to be equal to that angle also.
Oh, I see.
Right? So that one's 35. And that means that this is 35. So if we know that both of those is 35, right, then what can we say about this angle up here?
It's also 35.
Well, is it 35? Because we have this one right here and this
Oh,
angle.
you have to find 180. So if it's 180 minus.
And then what does that give you? 180 minus 35. There we go. Right. So again, the biggest thing that we want to think about with going through these problems is what are we given? Make sure that we're labeling it as much as possible. And then just thinking about some of those different things that are going on. Okay.
Okay.
Great job. All right. Another way to kind of think about that is because these triangles are the same, we know that this angle right here, 1, these are all going to be the same as well because these are isosceles and we know they split that middle angle. So if we know this is 35, we also know that this is going to be 145 and because this angle is the same as this is 145, right? So there's a lot of different ways you can go about these questions. You just want to start labeling things as much as you can, okay?
Okay.
Similar triangles. Have you worked with similar triangles recently?
Again, not recently, but I have an idea of kind of what it is, yeah.
Okay. So the biggest thing to kind of keep in mind, we know that triangles are similar when the angles are the same. So if angle B is equal to angle E, if we have two angles that are the same, we know that third angle is going to be the same, right? As long as two of them, and then we can just set up a relationship. So we can do this divided by this is equal to this divided by that, or we can do this divided by this is divided, or this divided by this is going to be equal to this divided by this, right? So
Yeah.
it all just is about the sides. When you get a couple of different things. So if you see questions where they have a triangle that's like this and there's a line through it, oftentimes it's a similar triangle problem. So you're going to want to redraw those two triangles, right? So you'd have that bigger triangle and then you have that smaller triangle that's in it, right? So be careful for those type of situations. And then also there's a situation where you have a triangle, say like this, and then there's going to be a line that's like this. This is actually going to create three similar triangles. Your first one is going to be that big one. Then you're going to have that small one that's right there. And then you're going to have the other one that's right there. So these are all going to be three similar triangles. And then the biggest one. Okay. So that's one thing to just kind of keep in mind with similar triangles. But again, whenever you get them, just draw the triangles, make sure that the angles are facing the same direction when you redraw it and then go from there. Okay. So this one says two similar triangles have the ratios of 2/5. The larger triangle has side lengths of 5, 10, and 10. What is the perimeter in inches of the smaller triangle? Well, we know that if this is 2/5, right, we can set up our triangles. Let's just draw these out. This is going to be, actually, let me make this a little bit better. So this is going to be something like this, where these are 10, that's 10, and that's 5. And then we're going to have some smaller triangle where we know that the size is 2/5, right? So if we want to think about the side of this one, what's going to be our side length? Well, if this one's 5 and we know that there's 2/5, well, we know that that one is going to end up being 2, right? And then what about this side? What's that one going to be? And what's that one going to be?
It's going to be
We can think about it. So yeah, so 10 over x is going to be equal to 5 over 2. So if we cross multiply that here, bring that 5 down, bring that 2 up, we get that x is going to be equal to 20 divided by 5, which is going to be 4.
Oh.
That's 4. And that's 4. So we can always set up that proportional relationship with our similar triangles, right? In the ratio. Does that make sense, by the way?
Yeah.
Awesome. And then what's going to be our perimeter of our smaller triangle? Great job. Okay. So just remember, similar triangles, you always want to set up some type of proportional relationship to be able to solve those, and you're good.
Okay. Whoa.
I know. I said the same thing. What's going on here? Yeah, it's probably something about the peaks. So we'll look at this. So okay. So, and this is another one where it looks pretty crazy and there's a lot of words, right? So this is why I like to read that last portion so I don't get too caught up in all the other material before I even know what I'm solving, right? So segments RU and SB interact at T. So point T right here. What is the value of H? So we're trying to figure out this. So we see that we have two triangles now, right? Because they're there, what can we start to do? We start to label our information. I didn't even look at the full question yet. I'm labeling the stuff so that I can get this out here. We know that this angle and that angle are going to be the same. We also know that this is a right angle that they show us. So that means that this angle up here has to be the same as that angle right there, right?
I see.
So now we have two similar triangles. So this is a point where we want to draw out our triangles, right? So I'm going to use Cami to help me out with this one. Cool. So we have that one. And I'm going to draw the smaller one right here. Thought I had it. Okay, awesome. Right. So this tall triangle, and this is why we want to draw them out, because it helps us keep track of what angle is where, right? Remember how we were talking about there's only a certain amount of stuff we can hold on to. And if we try to think about that, it's easy to get things flipped over or relationships mixed up. So we just always want to go ahead and redraw this one. So we know that's V, we know this is T, and we know this is U. And now we can start putting in our information, right? Just because we knew that it was a similar triangle, like we didn't even have to read all that other information to start. We could just set up our question and now we can come back. So it says, driver wants to determine the height in miles of a mountain using the reflection of the mountain in a nearby lake. The lengths of RT, blah, blah, blah. And the figure were found to be this. We know RT is going to be 12. So this is 12. We use a different color. So this is going to be 12. We also know that ST is going to be 9. We know that TU is going to be 4. And we know that UV is going to be 2, right? So now I set that part up for you. Now we're looking for this. So I'd like you to try and set up your proportional relationships and then let me know what that side length is going to be, okay?
Can I use like the, what is that called? Like the A squared plus B squared equals C squared?
You could do it that way.
Oh, but then there's already a ratio. Okay, I see. So it'll be 12 over 2 equals X
Close.
over 2?
12 over what?
Over 4.
12 over 4.
Yeah, equals X over 2. 3. So is it 3 ratio 2? Is the ratio 3 to 2?
Well, you multiply the 2 to the other side. So 12 times 2 divided by 4. What does that give you?
Oh, 24 divided by 4, which is 6.
There we go. Right.
I see. Okay.
So yeah, so you could use your quadratic as well, right? If you needed to for this type of question. But just understanding it's a similar ratio type of problem. This is fairly simple because you don't have to like square it and then square that and then do that quadratic stuff, right? We can just do our simple math, right? So whenever available, we try to take the math out of it, right? Because we want to make sure that we are just solving it to get the most points, right? So if we can do like something where it's a quick proportional relationship compared to like having like square different values and subtract things, then take square roots, like it just makes it a little bit easier for those. But we knew the similar triangle problem because we had two triangles that shared a central angle or a vertical angle. And then they also had a 90-degree angle. Cool.
Okay.
All right. So here's our special right triangles. They're not too bad to remember. What math are you currently taking, by the way?
Well, I'm taking pre-calc math analysis.
Pre-calc. Okay. So you'll get this in pre-calc. This is actually, these values actually, have you talked about the unit circle yet?
Not yet. I've heard about like what it is kind of yet. So first up.
It's actually not too bad to like, I'll show you a quick little trick for the unit circle. This is your unit circle. Actually, let me put it right here. So basically all you're going to do with your unit circle, you're going to have, so let's do this. So you're going to have 3 different values, right? You're going to have your X value and your Y value. Your X is going to be your sine and the Y is going to be your cosine, right? So basically all you're going to have is the point here. The first one is going to be 0, 1, right? Let me make sure that let me make sure. Yeah, that should be, oh no, I flipped it around. Yeah, there we go. I was like, wait, that should be 1, 0. Okay, there we go. So let me correct that part. So this should be 1 and 0. So your X is your cosine and your Y is your sine. Okay. And then all you do is you just count your numbers down from there. So this is 3, this is 2, this is 1. And then you do the other thing, the other way on the other side. So this is going to be 3, 2, 1. And then all you do underneath those is you write a 2. And then for the top part, you just write a square root. Well, square root of 1. 1 is basically square root of 1 is 1. You have your unit circle.
Oh, wow.
That's going to be your, right? So this is going to be basically your 30-degree angle. This is going to be your 45. That was an ugly 5, 45. And then this top one is going to be your 60 degrees. And that's all you do. And then the same way you would do it on the other side, you'd still go from that same way. So this would be basically your 3, 2, 1. And then the same thing, but just remember that because you're in the other direction, this is 1, 2. I only do this part right here. Square root of 3 over 2, square root of 2 over 2, square root of 1 over 2, whatever, right? But these are going to be negative now because you're in the bottom coordinate because your Y is negative down here.
Mm.
And then you do that same thing. So that's basically all your unit circle is. So these values basically are coming from your unit circle, right? Because if you're thinking about your x portion, well, where's your x coming from? Well, you have your square root of 2 divided by your 2, right? So that's basically this side that you're comparing to the other side. So this is where all these values come from. So these are related to your unit circle, which is actually kind of cool. But if you know these, it makes it a lot easier, and I'll show you why. So if we get a question like this in the figure below, WX has a length of 8 units and makes an angle of 85 with a horizontal. XY has a length of 6 units and makes a 60 degrees with a horizontal. What is the length of YZ? Or WZ. So we're looking for the length of this to this, right? Well, what can we think about? Well, let's break this up into 2 different triangles. If we break this up here, we know that this is 90. That means this is 45. And in this case, we know that this is 60. So we know this is a 30, 60, 90. So what can we do at this point? Well, we know that WX is 8 units and XY is 6 units. Well, if this is 8 units, then that means that this is going to be, we'll call this just, let's call it K. We can just set up our proportional relationships because we know this is 45, 45, 90. So we can say 8 over K is going to be equal to, or actually I'll do it the other way. I'll do K over 8. So then we make our math a little bit simpler. Is going to be equal to what? Well, our similar triangle, our hypotenuse for this one is 2x, and this one is going to be x. So in this case, we just have this over square root of 2 and 1 over square root of 2. And now we can set up our relationship. We can multiply our 8 over, if we wanted to use the actual values, we could say that this top part would be x squared root of 2 or x and x squared root of 2. But we see that those would basically cancel out, right? So then if we multiply this out, we get k is equal to 8 divided by the square root of 2. And then do you know how to rationalize the denominator?
You can do times square root of 2 on both sides from numerator and denominator, right?
Or, yep, so right here. So square root of 2 over square root of 2. And what's that going to give us? That's going to give us 8 square root of 2 divided by 2, which is going to end up being 4 times the square root of 2.
I see.
Right? So we know that this side down here is going to be 4 divided by the square root of 2. And just like that, we know that this answer wouldn't work. That one's not going to work. That one's not going to work. And now we just have this last part. If we know that this is 6, then knowing our special right triangles, this is our 30 side. So let's call this M. So what is M? So if we look back up here, we see that for a 30, 60, 90 triangle, this is 2x, this is x. So we can just basically still make our relationship. So we have M over 6 is equal to what? Well, it's equal to 1 over 2. So what is M going to be equal to?
M equals 6 over 2, which is 3.
Equals 3. Perfect, right? And now we can get rid of D, and B is our answer choice.
Okay.
So this is why we want to know our special right triangles, because it makes it a lot easier for us to answer some of those questions, right? If we didn't have it there, then we would have had to think about using like that quadratic equation, right? And that would have even been a little bit more complicated, because now we would have had to say that this right here is these are isosceles triangles, right? So we know that these sides are the same. And then we'd have to say that those square, 2 times those are going to be equal to this square. And then we have to do the square root part, and it would just be a mess, right? And then for the top triangle, I don't even think we would be able to fully solve that one outside of using like sine and cosine, right? We had to put the sine of 60 and this would be cosine of 60 is equal to 6 or whatever, right? So this is why understanding your special right triangles just makes things a lot easier, right? So check this one out. And I'm going to write the rules over here, or the triangles over here, and then try this one out. So this is going to be x squared root of 2. Then we're going to have so this is a 45, 45, 90. And then our 30, 60, 90 is going to be 2x, x, and then x square root of 3. Okay. So try out this problem and then let me know which one is the correct one. And remember, you can still use your process of elimination.
The total area, like, of all the sides?
Yeah. What is the total area of the whole figure?
So for the first one, the 44, 45, 45, 91. So I know that the 10 is the x square root 2 one, right? And so do I set it up like 10 times x square root 2?
So proportional relationship. So let's name this like, right?
Yeah.
Put those together, right? So everything right here, you can utilize, and then everything right there. So in this case, we can say over 10 is equal to what's in the spot for this triangle.
X.
Okay. And then what's in the 10 spot?
The x over square root 2.
And like I said, we can cancel out these two because we know that those are that. So it's basically just going to be over 10 is equal to 1 over the square root of 2. And let me grab some water for just 1 second while you're.
Okay, yeah, sounds good.
1 second. So did you solve for the bigger triangle?
For the bigger triangle? Oh, I moved on to the smaller one,
Okay, cool.
which I'm a little bit stuck on. Only because the it's a little bit different. So it's K, or I labeled it K for the bottom because it's a 60, 30, 90.
Okay.
And then it'll just be the K over 8 equals X. Oh, no. X over 8 over 2, something.
So yes, right. So this is where it gets tricky, right? What is this angle right here?
That is the 60.
60. So that's 60. This is 30. So always label those, right?
Mhm.
And now because of that, right? And we also didn't write out our area is going to be equal to our 1/2 based on height, right? But we want to make sure we do that. But then at that point, right? This is our 60, right? And this is our K. So the side that's opposite of the 60, right, is x square root of 3. So we have x square root of 3 on top. And then what do we have on bottom? Well, where's the 8 at position-wise? It's the hypotenuse. So that's going to be our 2. So then we can just multiply that over. And then that gives us what?
That gives K equals 8 times square root 3 over 2.
Which is going to be 4 square root of 3.
3, yeah.
Well, awesome, right? And then we also are going to have to find out the height of this one as well, right? So what's the height of this one going to be?
Since the side of that is going to be, so if 4 square root 3 plus 8, wait.
Well, this is the easiest one because this one is across from the 30 side, right? So this is going to be your x and your 2x. So we always know that this side right here, we'll just call it L, right? That's going to be always 2 times shorter than that. So that's just going to be 4.
Okay.
So we know that this is going to be 4 for this one. And then this one we have as our M. Figured out that that was going to be over here where we get M is equal to 10 divided by the square root of 2. And then we also have our height here. That's going to be the same, M, because it's 45, 45, 90. So in this case, we get 10 divided by the square root of 2 times 2, right? Or times itself, times 10 square root of 2. Oh, sorry. Forgot my square root sign. And then we know that that's going to be, so this is area equals 1/2 base times height. So this is 1 base, this is our base, and this is our height. And then we need to divide that whole thing by 2, all right? So we get 100 divided by the square root of 2, which we know that that ends up giving us, when we rationalize it, we're going to get 100 square root of 2 divided by 2, right? And that's going to give us 50. Sorry, I know I'm writing all over this place. 50 square root of 2, right? And then we have to divide that by 2, right? Because that's going to be this part down here divided by our 2, which is going to give us 25 square root of 2. Or sorry, 25 times the square root of 2. So we get that, this, and then on this side, we know we had our base is equal to our K. So 1/2, 4 square root of 3 times 4, which that gives us, what is that, 8 square root of 3? We do all the math out. So then we can get that B is going to be our answer choice.
I see. It's a lot of steps.
It is kind of like a lot of steps, but once you start to see some of the patterns, right, then it makes it a little bit easier, right? Because again, this is an ACT problem, but this is one that's like near the end of the exam, which is a hard problem, right? So because of that, it's not that it's overly crazy, but there are some small steps, right? So again, once you start to see that portion, it makes it a lot easier because now you have this, you know, you can just set up this relationship, which that one's not too hard to solve out, right? This one, when you're rationalizing the denominator, that's the only part that's a little bit tricky. So outside of that, that's probably like the only tricky thing. Let's just rationalize the denominator. But as long as you just set up your equation, then you should be good, right? So some problems will take a little bit of time. Others may not necessarily take as much, right?
Okay.
So this one, I'll just kind of quickly show this as quick as possible, right? So the diagram above shows the equilateral triangle inscribed in a circle. Lengths AD and DE have the same length. So AD and D. So this is, so we always want to label congruent sides, right? Have the same length of 10 centimeters. So these are 10 and that's 10, right? What is the area in square centimeters of the shaded region, right? So what we need to do is we need to figure out the whole region, right? And then we need to subtract just that shaded part, right? So if we see this, well, what can we start to do? Well, we know that if this is 10 and this is 10, there's a couple of different things that we can kind of think about. Since this is an equilateral triangle, we know that these are 60, right? So again, labeling things is so helpful because it's if we don't label things, and it just makes things a lot harder, right? So that's 60. So that means that this angle up here is 30, and that's 30, right? That means that this is also 30 because those are congruent, right? Which means that this one up here is going to be what, 120, right? So now that we have all of this information like listed, right, we can start to do a little bit more, right? We can do this one. And now that we know that this is 10 and we know this is an equilateral triangle, that's 30, that's 60. That means that this angle over here is also 60, which means that this is another equilateral triangle that's also 60. So that means that this side is 10. That means that this side over here is also going to be 10 because this is splitting this in half. So we just start to fill in things as we go along. And then from that, now we can get our base. And then we need to figure out what our height is going to be. So this is 10. And then we can do this portion. Sorry, just want to use a different color. All right. If we split that, then we know that this is also a 90 angle and a 90 angle. And that means that this right here is also going to be 60. So now we have another 30, 60, 90 angle. So this is going to be 10. That means that this one over here, because it's opposite of 30, is going to be 5 for this little small triangle that's right here. And then that also means that this side right here is going to be 5 times the square root of 3. And then that means that this height right here for this top portion is also going to be 5 times the square root of 3, right? So just like that, we were able to get most of this angle of this triangle, right? Because we have our 10 here, our 10 here, and then we have our height. So we know the area of the triangle by itself is going to be equal to our 1/2 base times height, which we said our base is going to be 10 times, let's see if we add those together, 10 times the square root of 3. So then we're going to get that this is going to be 100, blah, 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 for this triangle by itself, right? And then we have to figure out all these other lengths. The only thing is we would need to have our radius, and I'm not sure if we can get our radius from this one, unless we say that our radius is going to be, yeah, I don't know if we'll be able to get our radius from this one, right? Our radius would be in the middle for this one though, because it's an equilateral triangle inscribed in there. So our radius would be, oh yeah, we can't even do that. Actually, can we do that? I think we can actually. So our radius, we would go from here to there, which also would bisect this angle, right? And then if it bisects that angle, then that means that this will become a 60 right here. And this down here, it would now be a 30-degree angle. And this would be our right angle. So again, if this is going to be 10 outside of our 60, then that means that this little small part over here would be 5, just up to from here to here would be 5, right? And that means that this would also be, or no, sorry, if that's 10, this is x square root of 3, sorry. X square root of 3 over x, so over 2x would be equal to 10 divided by whatever we're looking for, right? So we could cross those two out, and then we get that if we cross multiply, we get that our height that we're looking for, or our radius, sorry, is going to be equal to 20 divided by the square root of 3, which is also going to be, radius is going to be equal to 20 square root of 3 divided by 3. So then we can use that portion to get our complete circle, right? Because we know that we have pi r squared is our area of our complete circle, which is going to be pi times 20 square root of 3 divided by 3. And that's going to end up squaring that one. So we're going to get pi times 400. And then that's going to be divided by 3. So that's going to be our area of our circle. So we see that gets rid of this one, and that one. And then we would be able to figure out the area of the last one, right? So basically, once we know this complete shape and we get the area of this one, when we have our 10 times our height of that one down there, then we know that this area, 1, 2, and 3 are all the same exact area, right? So we can break the remaining area down into 3, and that's why we're dividing that by 3. And then once we break that down by 3, then we can just subtract that specific portion over there, right? So there's a lot of different things that are going on with this one, right? But we have things and then starting to figure it out. So there are some problems that are going to take a long time. And I do want you to be prepared for this on the SAT or the DSAT, because some of the later questions are going to be very involved. So you just have to make sure you're considering what we're doing with those different types of questions, right? So again, a little bit challenging, right? With kind of thinking about what all we had to do for this one, right? We had to get the area of our circle. We had to get the area of our triangle. We had to divide that by 3. And then we had to figure out the specific portion. And then again, there's a lot of little small things that we had to do for this one. This is how some of the questions are, right? So just letting you know they can get kind of challenging, but if we didn't have our special right triangle, we wouldn't work on this. And this one thing to kind of keep in mind is that this is one of those things to consider with the exam. When I was talking about, we really want to make sure we're answering the easiest questions first, because every single question is worth that same amount of point value, right? If you get to something like this and it looks like it's going to take a while, skip it.
Okay.
You can come back later, and then maybe you can do something where you get process of elimination, right? Us being able to figure out that the area of the circle was going to be this right away allowed us to get rid of 2 answer choices. But again, we want to make sure that we're prioritizing which questions we want to work through and which ones we want to like save for later. Okay.
Okay. So like the harder questions and the easier questions, I guess, they are worth the same points?
Exactly. They're all the same amount of points, right? And that's why we really want to make sure that we're focusing on the questions that we know how to do first.
Yeah.
Quickly solve. And then for those later ones, just remember all the other students that are going to take the test are going to have similar questions that may take a long time, right? So when we're thinking about how we want to make the most out of our points and thinking that every exam is going to be curved, we want to make sure that we're answering questions as much, or answering the questions that are easiest first and then going from there. Okay.
Oh, I see. Okay. I didn't know that. I don't know why I thought like the harder ones were like worth more points, but
no, yeah, they're all worth the same amount of points, which is very interesting, right? So we want to make sure that we're optimizing our score as much as possible. Okay.
I see.
So when we have a question that's talking about angles in a triangle, we want to use the rule of 180, right? Where we know the sum of the angles is equal to 180. When we see something that's talking about side lengths, we want to use Pythagorean theorem, right? So Pythagorean theorem, I'm pretty sure you're probably fairly familiar with this one. It's just A plus B squared equals C squared, right? And then all we do for a triangle is just do that. We just plug that in. So in this case, we know that we have this ramp is equal to 13 feet. And then the height is equal to 13, and then this is 5. Have you heard about your Pythagorean triples before?
Triples? I don't think I heard about that one, no.
So there's certain numbers that with Pythagorean or with right triangles, we have the side lengths. So there's like a 3, 4, 5 triangle. There is a 5, 12, 13 triangle. There is a, I think this is correct, 7, 24, and 25. And then you have something like an 8 or 6, 8, 10, right? So in this case, why is that helpful? Because just by knowing that, we know that this side is 12 right away. So we didn't even have to use that Pythagorean rule, right? So these are like Pythagorean triples. But if you were to do it, right, we can do that part. So we get that 13 squared is going to be equal to 5 squared plus, we'll say x. So what's 13 squared? I think it's 169, right?
I think
equal to 5. And then we subtract 25 on both sides. And once you subtract 25, you get 144 is equal to x squared, right? And what's the square root of 144?
12.
There we go, right? So this is why it's good to know those Pythagorean triples, right? Because they make it a lot easier to solve some of these different types of questions where we don't even have to do the math because we already know what the answer is going to be. Awesome.
That's cool.
Yeah, sure. Yeah, there's so many little small tricks that are there, right? But like I said, Pythagorean theorem, I think you have that. So let's go to just some of our rectangle problems. So if we think about this, we have a rectangular prism. And then this is going to be basically our volume, right? So the volume of a rectangular prism, your length times your width times your height. And then your surface area is going to be 2 times your length times your width, 2 times your height times your length, and 2 times your height times your width, right? So basically this face, we're going to have that twice, and then for all of those other ones, right? So that face is going to be twice, this face is going to be twice, and then this face right here is going to be the front one, and then we also have the back one that's there, right? And that's where those come from. So when you get a question like this, you just want to make sure you're just doing the basic math, right? So by doubling each dimension, the length, width, and height, the surface area will be multiplied by a factor of what? So we just want maybe, right? So we have length times width times height, right? And then we're talking about the surface area. So what is going to be the surface area of this triangle?
The triangle?
Or sorry, prism, sorry.
Sorry. Well, there's no value, right? So would it just be like the 2UL plus 2HL plus 2HW?
Okay, cool, right? So we have that there. And then let's say, and then another thing that you can do, you can also plug in your own values for these, right? To kind of see. So let's just plug in a value. Let's say if all these are 1, what's going to be the area or the surface area of this triangle? Or, sorry,
6.
I keep saying triangle. Yep, it's going to be 6, right? So the area of this one is going to be 6. What if we double it and make those to 2 now?
2, that'll be 12, right?
So we'll see. So we have, this is 2, this is 2, and this is 2. So now we have 2 times 2 times 2 plus 2 times 2 times 2 plus 2 times 2 times 2, right? So what's 2 times 2 times 2?
16.
Or 8, right? And then plus,
Oh my goodness, yeah.
no worries. And then plus another 8, and then plus another 8. So that gives us what?
27? 24?
24, right?
Oh,
So we have, this is 24, and this one's 6. So how much greater is it actually? By what factor?
by 4.
By 4, right?
I see. Okay.
So the tricky thing is that when you're changing from a one-dimensional thing to a two-dimensional thing, oftentimes you're going to have to square that value. Or if you're switching from a two-dimensional thing to a three-dimensional thing, you may have to cube it. So when you're talking about volume, it's typically going to be a cubic distance more or a cubic amount more. When you're talking about area, it's typically going to be a squared amount more. So that's why with these, you just want to pick your own values, right? And then plug those in. This is a strategy that you can use, right? You don't have to use those variables. Just assign those variables values as long as they don't limit you with the values that you can use. And you can just pick your individual values and solve those questions that way, okay? For these questions, you basically should be able to just to kind of like plug in some of the equations. But again, we're doing that same thing, right? When this thing is changed. So we just want to basically add our values of our A, B, and C. And then we want to just vary that other value so that we can get it there. And then the same thing that we did for the previous one, okay?
Okay.
Awesome. Let's check out cylinders. So cylinders, again, similar thing. Just remember that cylinders are basically the volume of it is going to be your surface area times your height, because you're basically just taking a cylinder and just like stacking a bunch on top of them. It's a way to kind of think about it. So pi r squared times your height. And then your surface area is going to be similar. Your surface area, you're going to have your area of your circle, and then you're going to have 2 of those. So it's going to be 2 pi r squared. And then this, if you think about the cylinder part, if you like kind of like open it up, what's going to be the length of it? Well, the length is going to be your circumference, and then you're going to have your height. So that's why this one is 2 pi r times h. So that's what you have as far as those equations. And let's check out this question. So it says, Phil is an ice cream shop owner, and he is developing a new sugar cone for upcoming summer session. The volume of one of his new cones is this many centimeters cubed. What is the diameter of the circle or of the cone? Well, in this case, if we know that this is the cylinder, well, what is our equation for our cylinder? Well, this is going to be the volume of the cylinder. So volume is going to be equal to, so pi r squared h. Right? So all we have to do in this case is if we know the volume and we know our height, remember when we were talking at the beginning, we just want to plug our values in. So this is going to be our 30 pi is equal to pi times our radius squared. Well, what's our radius squared? We don't know. That's what we're looking for. And then our height is going to be 10. So then we subtract or we get rid of everything. So we divide both sides by our 10 pi, cancel out those. We know that this is equals to 3. So now we get that r squared is equal to 3. And then we can say that if r squared is equal to 3, then r is going to be equal to the square root of 3. And then the diameter is going to be 2 times the radius. So that means the diameter is going to be equal to 2 square root of 3. Cool.
Okay. Yeah.
So all we do in these cases is just plug our values in, and then we just utilize it from there. Okay.
All right.
All right. I know we're almost at time, but let's talk about this last portion. So as far as lines, slope intercept form, have you been working with these recently?
Yeah, I think we're using that a lot for pre-calc.
Okay. Awesome. Right. So with slope, just remember it's going to be your change in y over your change in x. Right. It doesn't matter which point you're using. And then just remember your distance formula is basically just your hypotenuse, right? That's why when you're thinking about your distance formula, it looks very much similar to your Pythagorean theorem, okay?
Yeah.
And the middle point equation, you can also think about your midpoint equation just using your different x values. So if you think about x here and x here, right? If this is 5 and this is, say, this is 11, well, how far are they apart? They're 6 units apart. So we know that middle part is going to have to be 3 and 3. So that means that the middle will be 8, right? So we got to think about midpoint formula as well. It's just the same thing as you just thinking about how you would add the middle of something, okay? So for these, again, since you guys are using this, I don't want to worry too much about this one. Just remember, these are going to be the types of questions that you're going to get. Sometimes they may not ask you for the value directly. They may ask you for a alternate type of value, right? So that's just one thing to kind of consider. But again, this one, just kind of like reading through it, just conceptually, we'll talk about it. The first line has a slope of 3 and crosses at this point. The second line contains points 4, -1. If the two lines intersect at point AB, what is the value of AB? So how would you solve this one out for AB?
You would just do what's it called? If they're intersected XY, so -3, or isn't it the y1 minus y2 over x? Oh no, y2 minus y1 over x2 minus x1.
For the slope, yeah, right. So in this case, right, we know the slope has a line of 3 and crosses at this point, right? So you can say that 3 is going to be equal to your different points, right? So you can kind of figure out what those are going to be from this one, or just kind of get that part. But you can also create your line from this, right? Because if you have your slope is equal to 3, and then you have this, right? Y is going to be equal to mx plus b, right? So at this point, you can plug in your values, right? So you know that this is going to be equal to,
Oh yeah, you can do that too.
right? It's going to be equal to 3 times, -3, right? And then plus b, and then you can solve that one out for b. And then for this one, you can create your equation that way as well, right? So you can get your slope from this one, right? And then you have your points, you can plug that in, and then you can get your equation, and then you can find out that point where they both are intersecting, right? So that's the way that you can kind of set up this problem and work it through. But again, just remember that you can always use your slope intercept equation to kind of add to those, okay?
Okay.
Does that make sense? Do you know how to go from here? Does that make
Yeah, yeah, I'm pretty sure.
Okay, awesome. Great job. Yeah, midpoints, again, distance. Yep, distance equations. One thing that I want to tell you about triangles, right? So remember that when you're thinking about triangles, the area of a triangle, and it's just another additional amount of information, is equal to 1/2 base times height. Just remember, even if you have a triangle that's like this, it's just going to be that vertical height. So this would be your base, and your height would be the height from this down to this part.
Yeah.
Okay. So it's always just going to be the perpendicular height is what you're thinking about. So you can use that one to do it. You could use this as your height and this is your base, right? You could use this one as your height and that one as your base, right? It would be something where this would now be your height if you did that, right? And then this part would be your base. So you can use whatever you want, right? Just remember that whenever you're thinking about a triangle, it may not necessarily always be the most convenient, but for a problem like this, if I was going to think about the height or the area of it, well, how would I do that? Well, I would consider this my base and I consider this my height, because now I know from this one, the X values, this is just going to be 3. And then the Y values, this is going to be 6. And then I know that this is going to be 6 times 3, 18, and then divided by 3, which is going to give me 9, right? So I just wanted to point out that thing about triangles, because there are some questions that are like that on the exam, okay?
Okay.
But yeah, this one's asking for the length of this. So we know that this is going to be 3. And then we can figure out this is going to be also, that's also, wait, this is 1, right? So we can do those, and then we can square that. 9 plus 1 gives us the square root of 10, right? So we get that. Okay, cool. Awesome, right? So again, just one of the things to kind of consider when you're working through those different types of problems.
Yeah.
All right. So the circle equation, this will probably be the last one that we go over. Have you seen this equation before?
Circle equation. No, not really familiar with that.
So this is the equation for a circle. This is like the graphical equation for a circle. So in this case, our graphical equation basically says that x minus h squared plus y minus k squared is going to be equal to r squared, where h and k are our center. So you want to make sure you remember this equation because they don't give it to you on the exam. And then this is going to be our radius. This is important because there's going to be questions like this that may be fairly simple to solve. But if you don't know that equation, then it makes it a little bit harder, right? So in the standard XY coordinate plane, the above circle equipped is graphed. Points lies on the circle and has coordinates 7 or -7, 5. If the line segments AB is a diameter of the circle, what is the coordinates of point B, right? So we know that in this case, this right here is our radius squared. So we say this is going to be x minus h squared plus I minus k squared is going to be equal to r squared. So we know that our radius is going to be it's going to be 5. Our center is going to be hk. So it's going to be -3, 2, right? So that's going to be our center, okay? And then from there, right, it says point A lies on the circle and has a coordinate of this, right? So A is going to be at point -7, 5, right? So if we have this circle and we have our center that's right here and we have some point that's right here, right? We know that because it lies on there, we can figure out the distance between there, right? So what is our distance formula? Well, we know that we're going 4 units in the x direction, and we know that we're going 3 units in the y direction. And guess what? This is our Pythagorean triple, right? And we know that our 5, right? So we know that porch is there, right? And then we said that line segment AB is the diameter of a circle, right? So now if we know that this is going to be 5, right? And we know that this is going to be in the other direction, right? Because this is negative and negative. So we want to go the other direction, 4 units? So we want to go 4 units that way, right? So, or 4 units the other way. So that's going to be a 1, right? If we're thinking about, because the difference in x is 4, and then the difference in y is 3. So we also want to go 3 units the other direction from this one, right? So this is 5, that's 2. So we will be going more negative, right? So then we get to -1. So our answer choice for this one is going to be C, right? So and we have to kind of think about it, but always draw out your picture. I probably should have drew it a little bit with the actual numbers so that you could see it, but just for time, sure you had that concept. So that's all you really want to think about with these. But again, these equations are easy because now a question like this, a circle has a center at 3, 0 and has points on the circle of this and this. What is the equation? Well, we know that this is going to be x minus h. So we can get rid of anything that's positive. And when we're thinking about our radius, well, how do we figure that one out? Well, we know this point is on the circle. We know that it's going to be 2 units that way. And then it's going to be 3/2 units the other way, right? So we can square those values and then add those together, right? And then figure out what our radius is going to be. And then we can use that to determine this part, right? So again, just knowing that equation is probably going to be the biggest thing. Last keynotes, just remember for parabolas, you have this equation. So make sure you're familiar with these. They don't not give you this on the exam, your vertex form. And then you also have your standard form. You can convert these two back and forth if you need to by just extrapolating out. And then just remember the biggest thing, your axis of symmetry is going to be your negative over 2a. Cool.
Yeah, that's what we're learning currently right now in math analysis.
Okay, awesome. Yeah, I think that's mostly it. SOHCAHTOA, again, just remember always set up your side lengths for SOHCAHTOA. Sometimes they're going to give you combination area questions. So you're just going to have to think about the area of both and then subtract. And yeah, I think that's mostly it. So outside of that, I just want to let you know. So enhanced prep. So we do have a lot of other free tutoring things or tutoring sessions that we put on just like this, right? As far as admission criteria, right? A GPA is going to be the biggest thing, and your class rigor going to be the biggest thing. So you really want to make sure that you're doing good at those. Your test scores are only going to count for around like 35%, 35% of your actual score, but you get a large amount of that admission decision based off a short amount of time compared to all the time they went to school, right? Also used for your merit-based scholarships. And then just remember, colleges look at all of these different things. So you want to make sure you understand how your application is going to look. As far as tutoring programs, we tutor all these different types of subjects, right? So I know you're doing the PSAT right now, but we provide service for these and other exams as well. And then make sure that you're saying yes to the right test, right? So I know you're PSAT now. One thing that you can do after you're taking your PSAT is we can look at your scores and actually understand what's going to be a best exam for you. Is it going to be the SAT or the ACT based off of your preference, right? So typically, if you're a really good math student and you do well on your math, then the SAT is going to be a little bit better because there's a lot more math questions that are on there. But you're not as good with the math portion, then the ACT would probably be there because you only have like 1/4 of the exam is full with math, right? So a lot of different things to kind of consider. And then just one last thing, as far as prepping options, we have a couple of different things. We have an on-demand course that's basically a self-paced course that you can utilize. We have a course as well where it's like small group where there's like maybe 1 to 6 students that are in there where you guys are all like learning and stuff like that. And it's small, like, and there's like lessons every time. And then there's also the one-on-one tutoring. So just a couple of different things to kind of consider. But like I said, the on-demand course, 24 hours of module instructions, do things by yourself. And there's also quizzes in each module, right? 2 full-length practice exams, and then 6 months of access to the course, right? So again, just some of the different things that we offer. You'll get a copy of this presentation as well. You'll be able to see these as well. But if you have any questions, feel free to reach out to our advisors. As you can see, we have a lot of other free events. So definitely check some of those out as well. And then, like I said, if you have any questions, always feel free to reach out. But yeah, thank you for your time. Any
I
questions?
know, thank you so much. It was actually really helpful.
Oh, great, great. Yeah,
Yeah.
definitely. I'm excited to see how your PSAT goes. That's
Okay.
like, stay positive. Remember, don't stay on problems that are going to be trappy. Like you want to move past those. A
Hmm.
question with the same amount of point value, and then again, just do your best. Right, the score just represents how good you do on that test for that specific day. But like I said, if you have any questions, feel free to reach out, and we're always here to help.
Okay, thank you so much.
Take care. Have a good rest of your day.
All right, bye.